Hi there. Welcome to our session. Today, we will talk about how United Airlines accelerates innovation with Amazon DocumentDB. My name is Rasham Gupta. I lead the product management team here in DocumentDB. I've been with DocumentDB for about 3 years, AWS for 5 years, and I have about 10 years of experience in clouds and databases at Microsoft and Meta before.
Good afternoon, everybody. My name is Paul McLean. I'm the managing director of the passenger service systems team for United Airlines. While I've only been at United Airlines for 8 months, I've been in the industry for almost 24 years now, working both on the technology side as well as the airline operations side as well. So thanks very much for having us today.
Great. So this is our agenda. We're going to first talk about, I'll give a brief intro to DocumentDB, what's new with DocumentDB, especially in 2023. And then I'll hand it off to Paul to talk about how United Airlines uses DocumentDB. By show of hands, how many people here use DocumentDB? So I would say about 25%. So I think it'll be a good primer on what DocumentDB is and what we've launched. And then it'll be a good segue into how United Airlines uses DocumentDB. So before we start, let's take a 30,000 feet view of where DocumentDB sits in the AWS portfolio of database services. If you look at the AWS portfolio of database services, we have our relational services, which is RDS and Aurora. And then we have our purpose-built non-relational services, which include DynamoDB for key value, Elasticache for caching, Neptune for graphs, TimeStream for time series, MemoryDB for memory database, KeySpace for wide column, and QLDB for ledger. DocumentDB is another portfolio non-relational purpose-built service for document databases. And so what are document database and why it's important? So what we're seeing in the industry is JSON is becoming more and more the most common data format that customers are using. This is due to 3 reasons. Firstly, JSON is a very flexible format. If you've used JSON, you know it's very easy to add new fields. And so that makes it very extensible. Secondly, modeling is very easy. Since it's pure plain text, it's very easy to understand without knowing any programming as to what's the context of the object. And finally, most of the APIs use JSON as a common API output. So as JSON is very prevalent, there is a need to store, query, and index JSON data. And that's where document databases come in, and they shine. Firstly, document databases have a very flexible schema that can be applied to JSON. Document databases allow ad hoc querying. Since you can add fields in the JSON object and your existing applications and queries don't break, they can still work. They provide flexible indexing. So if you look at the document databases, not only do they have like a single field, but you can have multi-field indexes, you can have geospatial, you can have vector indexes, you can have text indexes. So there are a variety of flexible indexing that you can apply on the same document. And what we're seeing across our customers is more and more the line between operational workloads and analytical workloads are blurring. And document databases are becoming a place where you can use the same data, no matter whether it's your operational workloads or analytical workloads. So Amazon DocumentDB is one of those, like I said, is a purpose-built document database. And it is a scalable, highly durable, and fully managed database service for operating mission-critical MongoDB API-based workloads. And if we double-click on it, what it means is there are like 4 things I want to talk about here. Firstly, it is very fast and scalable. What do I mean by fast and scalable? I'm going to go to the next slide and come back here, but I want to first talk about the architecture so you can better understand it. If you look at any traditional database that's built, traditionally the way it is you have like a bunch of compute nodes where you perform both the compute and it's also used for storage. So as your needs for storage increases, you need to add more and more compute nodes. That's not how we build DocumentDB. We've actually built it such that your compute and storage are separate layers, and that gives you a lot of flexibility, and it makes the service more scalable. How so? So firstly, your storage can scale independently of compute. A lot of our customers, for their dev test workloads, use only one compute node with our storage layer, and our storage by default is on 3 AZs. So you get the 3 AZ durability even with one compute node. Secondly, you might want to, if you have a need of increasing your read IOs or for your read operations. You can add up to 15 read replicas with DocumentDB. You can also vertically scale up, right? And because there is no need to hydrate the data, because the data is not stored in the compute nodes, let's say you are on 4XL, you want to go to 16XL compute because you have a need for that. All it is a failover. You just launch a new instance, make it the primary. Within a few seconds, your cluster is up and ready to go. There's no data hydration. So this enables customers to have flexible, fast, and scalable clusters for database clusters. We are also fully managed. By default, we take care of all the administration tasks that you may have. We have built-in high availability. I did talk about 3-AZ durability. We have security best practices always. And we take care of backups and patching, automatic. We also use CloudWatch monitoring and alerting. Enterprise ready. More and more enterprise customers are using DocumentDB, and they need high availability and durability. We provide 4 nines of high availability, 3-AZ durability. Enterprise customers also need region, they need HADR from region-wide outages. We offer a feature called global clusters, which I'm going to talk about in a few minutes. But at a high level, global clusters allows you to have a primary cluster in one region, and 5 secondary regions, which allows you to fail over in case of region outages. Security is always number 1 at AWS, and we have built-in security best practices with encryption in transit at rest. You have an integration with VPC and KMS. We're also MongoDB compatible. If you are using any existing MongoDB API-based database service, your application drivers and tools can work with no change. We also support hundreds of APIs, operators, and we continue to add more. So I already talked about the architecture. So why do customers choose DocumentDB over alternatives? There are 4 reasons why customers choose DocumentDB. Firstly, operational excellence. Customers like the operational excellence that DocumentDB offers. I talked about 3-AZ durability. Fast cloning is another. I'll give you specific examples. Fast cloning is an example. Let's say you had a cluster with 1 compute and storage, and that's your dev test, and you decide to start a production with three compute nodes and storage. All you need to do is clone your database and attach, which takes typically minutes, and attach 3 instances to it, and now you have a production cluster in less than 10 minutes. So that's what it makes your operational excellence faster. I talked about how easy, within seconds, you can scale vertically. We also enable you to do direct reads from specific replicas. This is also another, customers really like that. What this means is, let's say you have a cluster with 10 read replicas. So in DocumentDB, there are 2 ways to access your data. You can either go to the cluster endpoint, and we take care of doing a load balancing and picking the right read replica, or you can choose specific read replicas to read your data from. So in that case, you can say 5 of my 10 read replicas are for dev test, 5 are for production. And in that case, you can make sure your production read replicas are not, the load on that is not interfering with your dev test. So customers like that. Secondly, price performance. Our goal is to offer the best performance at the cheapest price. And we do that in different ways. Firstly, we offer a choice of instance types, including Graviton. I don't know how many of you here have used Graviton, but Graviton instances offer up to 40% price performance, and we pass that on to you. I also talked about our architecture, and because of that, you don't have to pay extra. If your storage increases, you don't have to pay extra for compute. We also launched a new feature called IO Optimized. I'm going to talk about it in a few minutes, but that's another way for you to save on costs. Customers also choose DocumentDB for our deep AWS integrations. Our number of integrations continues to increase, and I have a few more coming up. But with these integrations, you get the best of both MongoDB APIs and the use of AWS services that you can use in your applications. Finally, compatibility. There's no vendor lock-in with DocumentDB. Because we use standard MongoDB APIs, you can migrate in and out of DocumentDB. And what we've seen is every day we get a report of how many new customers, the APIs that they run, how many of those APIs we support. And on any given day, it's between 95 to 99%. So with the APIs we support, we're pretty sure most of your use cases, if not all, will be met with DocumentDB. So what are some use cases that customers use DocumentDB for? So a lot of our media customers store their media content in DocumentDB. and also their metadata for content management. A lot of retail customers store their catalog data in DocumentDB, and that is actually well suited because your catalog data can change, right? You can have more reviews, you can have more size. For example, if it's just retail, you can have more sizes and things like that. So it's always ever changing, and DocumentDB is a good fit. A lot of our internet customers build their mobile and web applications and store their data on DocumentDB. A lot of gaming companies store the user profile and personalization data in DocumentDB. And this is reflected in our number of customers. We have tens of thousands of daily active customers using DocumentDB. This is a list of our referenceable customers. The key thing I wanted to point out here is we have customers from pretty much every vertical, every industry, every geography using DocumentDB. You'll see travel customers, internet customers, finance customers, and gaming customers, retail customers using DocumentDB. Before I talk about what's new, I want to talk about two other concepts. First, I wanted to cover the cluster types. So DocumentDB has two cluster types, instance-based clusters and elastic clusters. The difference between the two is in instance-based clusters, you create a cluster and you define specific instance types. So you define a cluster with specific instance types, and then at that point of time, you can vertically scale up or down. You get about 128 TIBs of storage, and you can attach, and there's only one primary, and you can have up to 15 read replicas. So a lot of our customers use instance-based clusters, and they're quite happy with it. We have heard from our customers as they scale that they had a need for more than one writer, and they had a need for more than 128 TIB storage. So last year, we launched elastic clusters, which is an alternate way of spinning up your clusters in DocumentDB. With elastic clusters, we made it much more easier for you to use DocumentDB. You no longer have to choose your instance type. You just specify the number of compute units, and we take care of provisioning the instances underneath. You can have up multiple writers. So now your write IOs can be millions of writes, and we can also offer petabytes of data. And not only can you scale vertically, but you can also scale horizontally using MongoDB-compatible sharding APIs. So you have a choice of using these two cluster types. I also wanted to cover global clusters. We touched on it briefly. A lot of our customers, we're seeing more and more customers launch DocumentDB for global clusters, and actually this is becoming one of the main basic things that they need before spinning up a cluster. What is global clusters? Global clusters allows you to have a primary in one region and up to 5 secondary clusters in different regions. And so if you write in the primary, in under a second, it gets replicated across those secondaries. This is useful. We're seeing customers use this in two use cases. One is, of course, disaster recovery. If the region where your primary is hosted goes down for whatever reason, you can fail over to secondary. That's the first use case. The second use case, what we're seeing customers is a lot of our gaming customers have a high performance need, so they want low latency. So what they do is they write to the primary, and then they use the other secondary regions. If they have a game, it just picks the closest location and uses that for the read. So that was a good DocumentDB primer of what DocumentDB is. Now I want to cover what's new in DocumentDB, especially in 2023. So here's a list of features we've delivered in 2023. I'm not going to cover each of these. I'm going to cover each of these in detail in a slide, so I'm not going to talk about this right now. I just want to talk about the themes here, though. Firstly, AWS integrations and analytics. That's a big theme. We continue to integrate more and more AWS services with a special focus on AI/ML. We have some Gen AI announcements that I'm going to talk about with SageMaker Canvas integration, and then Paul also has some use case of Gen AI with DocumentDB. Performance and scale. Customers, as they're building more and more scalable applications, they want better performance, so that continues to be our focus, and we've done a lot of work this year. MongoDB compatibility. We continue to invest more and more in compatibility, and based on what customers want, we continue to launch more capabilities. Regional availability. Customers want DocumentDB globally. And then finally, security, which is our most important thing. Our goal is to enable you to build the most secure applications using DocumentDB. So that also, we've launched features around that. So let's talk about each of these. Firstly, new regions availability. This year, we launched DocumentDB in 3 regions: Hong Kong, Hyderabad, and Gulf Cloud East. With this, we're now in more than 20 regions, and you'll continue to see our goal is to be wherever AWS regions are globally. That's our goal. We've also launched Elastic clusters in 3 additional regions, Singapore, Sydney, and Tokyo. Query capabilities. Until last year, DocumentDB supported the MongoDB API 3.6 and 4.0. Customers asked for newer versions of MongoDB, so this year we launched MongoDB 5.0 API compatibility. And with that, you get more operators, new features, and 5.0 wire compatibility. We also launched the ability for you to do a managed version upgrade. So if you're using a 3.6 or a 4.0, you have a fully managed experience to migrate to DocumentDB 5.0. We launched JSON schema validation. With this feature, you are able to perform schema validation before an insert update. For example, if you have like a double field that you want to update with JSON schema, if it's not a double, it will not go through, right? So you can do JSON schema validation before document is inserted. We also continue to add operators and APIs for both instance-based and Elastic clusters. A list is here, and you'll see more of that. Performance and scale. Up to last year, our instance-based clusters supported 64 TIBs. This year, we've increased it to 128 TIBs for instance-based clusters. And then even an Elastic cluster shard can have up to 128 TIB. As a reminder, even though a shard is 128 TIB, Elastic clusters can support petabytes of data. Parallel indexing and index building status. So a lot of customers until last year the customers have to build indexes, right? And one of the things we heard from customers is it used to take, especially when they have large documents, as their document sizes are increasing, it used to take them hours to sometimes even days for index creation. And that was a big pain point. So we did 2 things. One, we added parallel index build, which, as the name suggests, allows you to create indexes in parallel. And I'm going to talk about that in more detail. But in addition to that, we also added the ability to see the status of your index build. So you get feedback, and you know how much of it is completed. So let's go double-click on faster parallel indexing. So parallel indexing works on 4XL or higher instance types. So as long as your primary is 4XL or higher, you can use this. The way it works is you can now define the number of threads you want for it to use to create the index. Typically, you can use max of 50% of the total vCPUs that are available for that instance, for your primary. And that is then used for index creation. This has reduced latencies from days to hours. So customers are seeing significant improvement. And what you can do with DocumentDB is you can, like I said, if you have an index create, you can go from like a smaller instance to like 16XL. It takes 30 seconds for the failover, create your index, and then you can go back down to save costs, right? So, and all this is possible because of our architecture. One call out I do want to make is the more threads you give for index creation, obviously it's taking those threads away from your querying operations. So you do need to plan for it to make sure it doesn't interfere, or you need to scale up, vertically scale up to a higher instance type while index creation is happening. In addition to indexes, we also launched some engine improvements, specifically around document compression and operator improvements. So customers have asked for document compression, and the reason being they wanted better, lower storage and I/O costs. That's our focus, like I said, to give you better performance at a cheaper price. So now with DocumentDB this year, we enable document compression. For documents whose size is greater than 2 kilobytes, it's actually compressed. It saves you on storage costs, and then less data has to be transferred over the wire. So that means lower I/O costs. We also launched operator improvements. So customers told us that some of the operators they were using, like $LM match and $in, which were more frequently used, when they were using it in a nested fashion, they would take longer than expected. And so both of these we fixed with 5.0. And I just wanted to share some data. On the top left, I don't know if you can see the numbers, but if you can see the performance of $in. As the number of nested fields increases for $in, you can see it's a magnitude of orders difference between DocumentDB 4.0 and 5.0. So that's the top left chart over there. If you look at the lower chart, it shows you that it's a fraction between the IOPS reduction is a fraction between uncompressed and compressed, right? So again, that is direct cost savings for you because you have less IOs to pay for. And finally, load performance with compression, you can see up to 60% improvement. If you have a compressed data, that's actually, again, performance improvement for you because 60% improved performance as you load your data into DocumentDB. I talked about security. DocumentDB already supports encryption at rest and encryption in transit. A lot of customers said they are looking for, like they have sensitive data and personal identifiable information. So they want a way to store that data encrypted in DocumentDB. And so we launched client-side field-level encryption this year. With that, you can use your own keys from KMS, encrypt the data on client-side, and it's stored in DocumentDB in an encrypted format. Let's move on to AWS integrations. Earlier this year, we launched AWS integrations with Lambda. The way it works is you can now trigger Lambda functions from change stream events. So now in real time, as changes are happening in DocumentDB and they're reflected in change streams, you can now trigger Lambda functions. So again, it gives you more flexibility in using more AWS services using Lambda based on your DocumentDB database. Integration with analytics is a big focus for us. Last year, we launched JDBC driver, and we've seen many customers use Tableau, for example, to connect to DocumentDB. This year, we announced the ODBC driver, so you can connect applications like Power BI to connect to your data in DocumentDB. Last week, so Gen AI is on everybody's mind. A lot of customers have Gen AI applications. So last week, we announced the in-console integration of DocumentDB with SageMaker Canvas. And what this enables you to do is, if you have data in DocumentDB, now without writing a single line of code, you can take that data, bring it to SageMaker Canvas, where you can create forecasting regression models, train them, and then publish to QuickSight. So all that happens without you writing a single line of code, all with our in-console experience. So that is now live in GA for you to use. And with that, we expect to see customers use more and more DocumentDB data for like their Gen AI and AI/ML use cases. Saving on cost is our focus, as I mentioned a few times already. So last week, we also announced DocumentDB I/O optimized. What does this feature do? So taking a step back, before this feature was launched, outside of backups, we used to charge customers on 3 dimensions: compute, storage, and IOs. Compute and storage are self-explanatory. IOs was one where customers would often see predictability, depending on whether there's a read workload or a write-heavy workload, right? And so customers would often say that they needed a more predictable way of using DocumentDB and for their costs. So we launched DocumentDB I/O optimized, which is a choice that customers have. Customers can continue to use their current pricing model, or they can switch to this pricing model. With this pricing model, there is no more charge for IOs. Customers pay extra, 10% extra on compute, 3 times on storage, and IO is included. So not only that, if you are using IO optimized, you will also see 15 to 20%. We have seen performance gains when you're inserting your data or for write-heavy workloads. So how do you choose between the two? So if you are looking for default storage type is the standard, which I just talked about, like by default, which you are charged for IOs. And really, if you don't have, if you're like a primarily read-only workload and you don't have a lot of IO workload, the standard pricing is a good choice. But if you are looking for price predictability or have a high IO workload or a high write throughput, you might see better price performance with IO optimized. So that's what's new with DocumentDB. I'm going to now pass it off to Paul to talk about how United Airlines uses DocumentDB.
Good job. All right, thank you very much, Rashim, for that great update on DocumentDB. Let me talk to you a little bit about our United Airlines journey that we're working on right now. So start off with a little bit of information. What is a passenger service system? All right, who flew here? Who flew here United? Thank you very much. A passenger service system is a series of critical systems that the airline uses to control inventory, your reservations that you do, when you go to the airport, and all the different services underneath it that communicate to the outside world, such as your travel agencies or other airlines. At United, we have a mainframe that does that. It's called Shares. It's based on a legacy technology which has been around for over 50 years. That has been the cornerstone of United operations of the airline. Every booking that you make, every time you check in at the airport, everything that you do, all 144 million passengers that we have passes through that mainframe. What we've done, though, over the years is we've slowly started to externalize some of the pieces and expose them through various multiple integration layers that are able to, so you can have the more friendly user look when you check in on the web or your mobile app. But at the core of everything that still happens beneath that is our mainframe system, which is over 60 years old. Not the system, but the platform that it runs on. So what are we doing right now? Well, right now United Airlines is at a bit of a crossroads. This mainframe that we're running it on, the people that run the mainframe, all very great people, but they've been around for a very long time. The people that nobody comes out of university anymore and says, hey, I want to code an assembler, right? So what we're doing is we're planning for our future. We also have to work to change what, we also have to work to ensure that we meet rising customer expectations. I'm sure all of you have shopped on Amazon. When you go to do your shopping, you know exactly what you're buying, you know when it's going to show up, you know if something happens, how to get a refund. Everything's very transparent to you from A to Z, right? And what we're trying to do is to ensure that we start to give that type of visibility out to our customers and employees. There's also a lot of industry momentum going on. Over the last number of years, the airline industry has been talking about modernizing. The airline is very restricted to things that were decided 50, 60 years ago when electronic reservation systems were first built. Does anybody here know what an e-ticket is? Thank you for the 3 people from the airline. No. Electronic tickets are what the industry uses to be able to reconcile. It's like your bill that sort of goes along with you as you start to go through your journey. And that is something that is industry standard that all airlines follow and all travel agencies follow. But these are things that the airline is kind of saddled with that kind of holds us back from doing certain new things that we want to do, offering new products and so on. And this is where I'm talking about untapped product potential. The airlines are there to help ensure our customers have the best and smoothest journey that they can have, from everything from when they purchase to what they're buying, all the way through to when they get off the aircraft at their destination. And this modernization and transformation that United Airlines is going through is going to help to do that for our customers. So as I was sort of going through, what we have today is a legacy system that's built around industry standards that we're trying to change to a modern, more customer-centric offer and order management system. We have mainframe technology that is very monolithic, and while you can carve some pieces out, it's still very hard and challenging to do. We want to make this a platform-based solution where we can pick and choose the best of breeds of the pieces of new technology, new technologies out there, and bring them together to give you the best experience. Integrations into our existing mainframe that we have right now are many. And this causes some challenges as you try to get information out in different ways to do it. We have things from screen scraping that is going on to the most modern technology to still using teletype messages to communicate back and forth between airlines. We're looking to set ourselves up with a common integration layer, a modern common integration layer that'll be able to unlock all the potential of the data that we're going to have in there. We have a lot of manual business processes and a lot of processes that still rely on people using a green screen. A green screen is basically a window into a mainframe, and you're looking at the real text of what's going in there, the cryptic information in a mainframe. And I always laugh at this when you see videos or stuff of people at an airport asking to change their flight and somebody's banging away on the keyboard and they're running like 50 or 60 commands. They're actually working for United Airlines. Some of them are working in a green screen to help change your tickets or to help make sure you're moved along your way, right? So these are things that we're looking to be able to change the way that our employees can service the customer and also change the way that our customers can service themselves. So it's about improving the experience, the overall experience to get to your destination safely. So where are we looking to go? So our PSS of the future is kind of broken down right now into about 5 different areas. And some of these things you've sort of heard about where Rashim was talking about, but the way we're sort of looking at it is when you go to look to purchase something or look to buy something on the website, you're shopping, right? It's just like when you go on Amazon and you're looking through and you're looking to buy different products and put them together and get a bundle and so on. These are what we call the offer stage. These offers that we make today, though, are still built on legacy systems that were built, once again, 40 or 50 years ago. What is happening, though, is that we're constrained by certain things like how many different booking classes we can have. We can have 26 booking classes. That's all you can have. We have different fare basis codes. These are all airline lingo that just holds back the industry because you have to make all your new technology fit into these little new old boxes that are there. Our order that we're looking to build and that we're building on DocumentDB right now. This is the part of the system which is what we call today your record locator or your PNR. This is where everything about who you are, where you're going, what you've purchased, how we've delivered that to you or how we haven't delivered that to you, or what are some of the special things that you're looking for, that is what's all going to go in the order. Today, all that information is stored basically in a flat file on a mainframe, right? So it's very unflexible of how you can access that. We have the flight management part, which is about when you go to the airport, you check in, did we deliver something to you? And then we have our foundation. Our foundation is there to pull all the systems together. This is where we have, like we said, our integration layer that we're going to be looking towards. And also, it's going to be translators. The airline industry doesn't do anything very fast. It takes a long time. E-tickets were introduced in 1994. E-tickets was to get away from a paper ticket you used to give when you get on the airplane, like you held your boarding pass, but you took a little coupon out. What happens now is this has all been electronicized, but it took many, many, many years to get there. And I got to tell you, some airlines still aren't there yet, right? So we have to build technology that's going to work with the future, built for what United needs to deliver to our customers, but we still have to work with every other airline that's our partner, every other travel agent and GDS, because they are a significant part of our business. So we have to make this work back and forth, interoperability. So let's talk a little bit about the journey that United's been on over the last couple of years. I wasn't there from the beginning of this journey. I got to shout out to my team that have been working on this, and some of them were in this room. But they've been working on this journey of airline seating transformation. So when you go to purchase a ticket on United Airlines, you are buying the ability to travel on the airplane. Then you are choosing the seat you're going to sit in, so you actually get the physical seat that you're going to go towards. So over the years, we've exposed this as nice pictures on the website or on the mobile app that you can do. But once again, in the background, there was a lot of hoops going on to make that accessible in the mainframe. And once again, mainframe used to have seat maps, which are X's and O's and dots on a screen that you used to have to choose your seats from. So what United has looked at is that we need something that is going to be scalable. As we start to build this out, we want to do rapid innovation. So if we see something we need to tackle quickly, we want to do that. And we want to have real-time data validation for this. We still need to keep our mainframe, which is the core of our core operating platform for our airline, and we still want to keep that in sync with anything else that we off-host on the system. We want to make sure it's accessible. One of the most frustrating things for a customer is not being able to get the truth, or they get 2 truths, or 3 truths. Why did this change? Why did this happen? You ask one person to give you one answer, they ask another person to give you another answer. It happens, it's unfortunate, but this is a factor of so many things have been off-hosted and built out and built into different areas. You're not necessarily always using the single source of truth, you're using that source of truth that they're looking at right now. We want to empower our customers and employees to have the accessibility to that information that they need and be able to leverage it to make their journey. We also wanted to start towards our new data model, right? So I talk about this. We're looking to go from a PNR to an order, right? Order is, like it's set up, as a database with all the information that you have of where you're going, all the information, whether something has been used or not, whether you've been refunded or not. This is what we're looking to set up as our order management, as our order database. And then we want to start to expose, pull out our customer information. Right now on these PNRs that you have, everything is there. All the customer information, all the personal information is stored in with all the flight information, with your baggage information. And if your flight goes through a change or a cancellation or something happens, there could be 500 lines of information on these PNRs that people have to go through and figure out what happened. So this is what we were starting to look at. So when we look at seating, seating was a place to start. This was a big deal. Like I said, seating, that's what we sell. We sell seats on airplanes to get you from A to B to your destination. So we had over 30 different applications that did something to do with seating at United Airlines. And every one of them, some did it the same way, some had a little bit different. Some, when you did a rebooking, you might have got a similar seat or not, but not everything was the same. So it was all a mixture of many different applications. Managing of seat maps. A seat map is what's on an airplane right now. A seat map is what seats are available, what the characteristics are they window or an aisle. That was all managed in the mainframe, right? All with X's and O's once again, how it's managed. So a lot of that stuff we decided this is a great place to start, a bold place to start, but it was a great place to start to pull the information carve that information out of the mainframe. So once again, we had a flat file data structures, very difficult to change. 90% of our code was in assembler, right? Very hard to change, very hard to update, not very flexible. Takes a long time to do anything if you ever worked in mainframes. Multiple interfaces, multiple ways of doing stuff. And once again, it's a complex platform, right? And if you need to scale up to do things, it's expensive. Mainframes are expensive to run. So where we got to today is all of our applications now come into one, what we call the seat assigner service. When it goes to that service, it looks over at our Amazon DynamoDB to find out the seat inventory, what is available, what seats are available for you to look at and for you to choose. And then once the customer has made the decision, it'll actually make another call over to to DocumentDB and make the record there in what we call our new order, which has the customer's name, information, where they're traveling to, what seats they chose, and if there's any changes to that, those will actually be recorded in DocumentDB as well. What's also important about this is we have to sync this information back to our mainframe, and it's almost happening real time of all these situations that happen. So DocumentDB gives us a new flexible databases that can give us new capabilities for our customers. It gives us a common set of isolated rules that we could sort of build into this microservice architecture, and it was in the cloud. So what we need to scale, if something starts to go wrong, airlines go through peaks and valleys, right? When some big storms hit all over the place, airlines are crazy trying to rebook their passengers, trying to get them from A to B. Lots of people on the phone, lots of people computers. You get a scale and a massive uptick of how many transactions are going against your system. So you're normally scaling mainframes to handle the peak of what's going on, whether it's, and if you're handling for those 2 days, you've scaled your mainframe to handle that, to those peaks. This gives us the ability to sort of scale up and down as we can start to plan and handle how much data we're going to have to store, how much access we're going to require for it. So like I said, Amazon DocumentDB was our chosen database. As Risham mentioned, easy, adapt is changing schema. What we've done now is a starting point for what we call the United Order. It's a starting point. We want to grow that, so we want to have something that's flexible. We want to make sure that it could scale reads. When you go for bookings, when you make your booking, you can make it 300 days out or 300 and something days out. When you've made your booking and you've selected your seat and stuff like that, unless something changes, nobody's going to look at that information up until you start getting close to when travel is going to happen. When you start getting close to travel happens, there might be an aircraft swap or an airplane changes, which causes a reaccommodation and your seating gets changed and stuff like that. But but up until that point, a lot of the information is just about read. It's not about writing back and forth back to the data. The consistent indexes and capabilities to add ad hocs as new patterns emerge. Once again, we need this to be flexible. We need this to change as we need it to change fast. Right? And the ability for global customer support to perform fast cross-region failover. This is going to become a critical part of the operation of the airline. Just like our mainframe, it needs to be stable, it needs to be strong, it needs to be performant. It needs to have redundancy. It can't go down. If this goes down and you can't figure out where people are sitting on an airplane, it doesn't go very well at an airport. Our seat inventory was also done with Amazon DynamoDB, and our history was done RDS, and our archive is Amazon S3. So we've used a lot of the different Amazon platforms to develop this entire seating capability that we've actually pulled out of our mainframe, or in the process of pulling it out right now. So along the way, we had to work with AWS. We had some challenges that we faced. One of these ones is what I sort of talked about, is we have data that needs to be accessed really far out, and we have data that needs to be accessed really like close in. And the close-in ones are doing a lot more churn, or a lot more read-writes on it. So we had to figure out a way to have the application logic to look up across different selections. There was no inbuilt way to do that with DocumentDB. Failover capabilities. While we talked, there's some great failover capabilities there. The automation of it, we had to do that in-house. But we worked with AWS to get there to figure out how to do it. And some of the stuff that we've been talking about has been fed back into what Rashim was talking about earlier today. Also, I talked about the eventing. A lot of the data that was coming out of the eventing, once again, was not really usable right off the bat for us. So we had to build custom, meaningful events. And we had to have our own layer on top of that to be able to understand it and event it out. So let's take a little shift a bit to the future. And we talk about Gen AI, right? We've all heard about Gen AI for the last 6 months. 7 months, it's become very popular. What we started to look at this opportunity as we transform our mainframe and transform United Airlines is how do we take generative AI and build it at the core of what we're looking to do. So as an example, we started with a simple use case. And if you see those 4 quadrants there, this is that green screen I'm talking to you about that some of our agents use to be able to see what's going on. We took the information from our various order and inventory, order and seating history that we have, and we extracted it out of the DocumentDB, and we were able to load it into Amazon Bedrock and train it how to read what we call cryptic PNRs and read the history. So if you had multiple lines of changes in there and you asked somebody, hey, why did my seat change from 14 Delta to 36 Foxtrot? What happened for that happen? If you were to go to certain agents, they would look at you and say, sorry, sir, I don't know. Or sorry, ma'am, I don't know. Because it takes investigation to do that as to what had happens. What we trained with generative AI to is we trained it how to read the matrix of the cryptic information. And from what we exposed from DocumentDB, we were able to look at it and say, okay, if somebody asked a simple question, why did my seat change? It would be able to go through the history, see all the different events that went on and say, your seat changed on this date because there was an aircraft change, due to a schedule change, due to this and that, and give the real-time answer. So we're working on that right now, is being able to pull that information out of DocumentDB. And then once we pull it out of DocumentDB, running it through and actually having some of our GUIs that we're building for our call centers or in airports to be able to ask these simple questions or have some of this stuff pre-canned so that they can get the information out without having to do deep investigation as to why something changed. So this gives us the ability to build generative AI at the core of what we're doing. Do we have all the answers for it? No, trust me, we don't. We're still trying to figure out as we go along. But it's very exciting, and some of the feedback we've seen so far already has been really, really interesting, right? It's mind-changing when you tell people they've just looked at something that was 500 lines, and in 2 seconds you can explain why something has happened. That's going to be an exponential change for how we serve our customers or how our agents serve our customers. Why I'm bringing this up is because we're talking with AWS right now of how do we make DocumentDB directly interfaceable, right? I know we talked about some of the things we're talking about, but we're looking to do this at our core for everything we do using generative AI, right? How you interface with the data, how you could have Gen AI running in the background. And if for some of you, it may have showed up at the airport and you go to check in and it tells you, sorry, I can't check in because something's out of sync or you haven't paid a fee or something yet. It would have been nice if you'd have known that before you showed at the airport. But this is where we have Gen AI. It's working in the background, going through all the different phases of your journey and saying, oh, Mr. Smith, sorry, you haven't paid you have a fee that you still haven't paid yet. Send it out a note, ask me if you want to pay it. That's done instantaneously instead of that being offloaded to a contact center or to somebody else or stopping you at the airport from when you actually get there. So where is this taking to us? So this is a multi-year and a challenging journey for any airline. My last previous history where I was before, they took a little bit of a different step. They didn't go through a transformation, but they moved from off a mainframe to a modern PSS system, but it's still based around all the old legacy capabilities that you have of e-tickets and PNRs. So that's one option to do. United has taken the other option of trying to transform. And this is not going to happen in 2 years. This is going to be a multi-year journey as we start to carve up the mainframe. We want to start with a solid foundation to get there, like we sort of talked about, DocumentDB, Amazon Bedrock that we talked about. How do we set up our foundation? What's the communication? How are we going to work with our other airlines? How are we going to work with our other partners to ensure that we can start to work together to move the industry away from this legacy that it's had over the last 60 years? And how do we start to transform it for the future? We have to make sure we coexist again, very important. And we want to make sure that anything we have is going to enable as rapid innovation. I'll give it an example. There was new rules that came in with seating where children had to, we had family seating that had to happen because of a regulation where if somebody's flying, they should be able to sit with their children. But if they didn't choose the seats and it didn't happen, it was up to the airport to figure it out. Then if the airport didn't figure it out, it was up to the flight attendants to figure out on the plane. And that's just a complete disaster for getting an aircraft out in time. And it's also not a great experience for our customers where all of a sudden you're not sitting with your child anymore or sitting with your family that you want to travel with. So because we had offloaded some of this seating, this gave the ability to adapt to that quickly and offer our customers self-service capability to choose their seats together. If they're a family, meet the criteria of under a certain age, they're traveling together, they're on the same, and they can actually choose their seats they want to sit together. Before you had to call somebody. No more of that. It's all done by the customers themselves now. So this ability, if we had to do that on a mainframe, it would have taken us months to do that, but it was done within weeks that it was capable to do. So this has been a great partnership and a great journey so far with AWS. We continue to share information, we continue to improve, and we're looking to see what the future is going to hold. Like I said, this is a very exciting for anybody who works in the airline industry of where we're trying to go here. Very challenging, but I'm looking forward to the adventure that we're all going to be going on for it. So that's what we have for you today. Rashim and I, we're going to take some questions off stage. So Rashim will be over here. I will be over here on the left. If you have any questions, please come up and talk to us. I'd like to give you a little bit more personal service of one-on-one instead of people shouting out questions in the room. So with that, thank you very much, everybody. It's been a great pleasure to talk to you today.